So
having a new abstraction, but without the benefits, rather.
Yeah. So Brad, since you're already on the mic and we see you all, I think we just finish coffee break and start with the next session.
The very first Windows.
So yeah, Brad will talk about ESP32 forth. Interesting. And yeah, Brad, please go ahead and tell us about your forth. Oh, and now we can't hear you for whatever reason. Brad, your mic is still muted.
All right. Sorry about that. Okay. So let's see. So one sort of branding change I wanted to announce and share with this group. We powwowed a group of us and have concluded that given the extensive marketing that Peter has done around the ESP32 forth brand name, that we're going to on the ESP32 platform rebrand what I'd previously described as micro E4 as the new ESP32 forth V7. So you'll see that naming change sort of propagate through various things. And there's a new website. The old website works; it still works, and will continue to work and redirect. But there's this website for it. So I'm going to talk about sort of some things that have been improved since the last time since last month, and we'll sort of show some of them off. Vocabularies, block editor, adding words. So vocabularies. I've added vocabularies to the system. I've done a little bit of a strange thing with it. I've done sort of a hybrid between, I guess what you could say was FORTH2020 style vocabularies, where where when you define a vocabulary, it changes to the vocabulary in which it was defined, and FORTH83, where there's a vocabulary stack. Essentially, the model is that I sort of do both at once. And so when you define a vocabulary, it changes to its parent by default. Sort of the usual things work. You can, there's a fourth vocabulary that you can switch back to. There's definitions that takes the current context and makes that the active vocabulary. And there's VList that lists the current vocabulary, and words that lists sort of the current vocabulary in the entire chain. But there's this, let's see, one eclectic word I wanted to mention. I use this quite a bit. One of the reasons that I was motivated to add vocabularies is that it was getting to the point that the number of words that we have bindings for in ESP32 forth are so numerous that when you type in words, you fill up your screen. And so I was incentivized to have vocabularies to sort of isolate some of the internals of the system. Of course, the system bootstraps itself, and a lot of the words are defined before vocabularies are defined. And so I've got this word transfer that pulls a word and brings it into the current vocabulary. There's the usual also only an order as well. And then here's the sort of one concession to compatibility with FORTH83 and beyond vocabularies. So by default, vocabularies will change to their parent. So if you and I'll show in a second what that means. But if you want to make a vocabulary just be isolated and depend solely on the word order, you can seal that vocabulary. So let me pop over and oops, I need to. Oh yeah, I got. So actually the text is bigger on here. So let me do this for. So I've got a. Actually no, I'll do it over on the Arduino terminal just for. Okay, so can folks see that? Yeah. So now when you type words, you get a much smaller list of words, and one of the reasons is that things are sort of isolated into vocabularies. There's a vocabulary internals that if you list just those words with VList, has sort of all of the leftover stuffing from the bring up of the system. In general, this is something you won't need to use the innards of, but it lets me give an example of, you can type the word order to get the word list, and you'll see that if I type words, I've got sort of all of the things. So you get first the internals and then the parent word list, which is just the fourth word list. If I go back to the root here, I can define a vocabulary foo. I can say foo definitions, and then inside of there, I can define some word that does something. If I vlist, I get just that word. If I can go back to the fourth word list, foo is not there, test is not there. If I go into foo, test is there. So all of the typical things. Oh, by the way, one sort of other valuable thing that this does is that a lot of the Arduino specific words, or sorry, not the Arduino, I'm sorry, I'm confusing myself here. So for example, a lot of the bindings are now in a separate vocabulary. For instance, all the serial, low-level serial port words are off in the serial vocabulary, or the Bluetooth. Actually, oh, this build doesn't have the Bluetooth stuff, but let's see. Oops. Let's do. Let's go up to fourth. What's another one? We could look at the. Oh yeah, the streams, for example, are off in their own word list and so on. So helps with organization. Mostly just for fun, and I enjoy blocks for whatever reason. I added blocks and a block editor, so there's now sort of the usual things that sort of one you can use to refer to choose a different file, but otherwise it defaults to spif blocks.fb. There's list and load. And then I have an editor. It's sort of this is just a line editor of my own sort of quirky choosing, largely because it was small and simple. Let me give the tiniest demo of that. So if you list things that you start with an empty block, I can wipe that. Oops, I got to go into the editor vocabulary, and I can then wipe that block out. I could define a testing line there, and then let's say I do. I need to have a better go-to example of testing words. So you add a line in. Oh, I should say. So most of the words, the way they work is they take a line number as a prefix, and then you, for example, R lets you replace a line. So you do like 0 R, and then the text, and it replaces the content of that line. You can insert a line, you can delete a line, you can erase a line, that sort of thing. And let's make line 2. Oops, go up here. Line 2. We'll actually call that word. You can do N and P to move backwards and forwards between blocks, and that will persist on the storage on the device between runs. So if I, oops. Do I have a typo there? Testing not found. Why not in? Oh, I'm in a bad state for my vocabularies demo because I'm defining into one word and then using it elsewhere. So you can do that. If you do by, it reboots the board. So the board just came up fresh. I can now do 0 load and the program is still there. So. That was the demo. How are we doing on time? I'll briefly touch on this. There's documentation on the website, but I wanted to highlight. I know a number of folks are potentially interested in adding words to the system. I wanted to highlight how easy it is. So you'll find if you look at the source code, there's a bunch of these X macros lists where they consist of a name, an alias name that is there because I was not able to figure out a clever way to avoid needing to have a secondary name, and then the code for each individual word. And so adding your own words is really easy. I've got a shortcut Y. If you've got a word that has only letters and numbers or underscores, fits as a C identifier, you literally can just have the name of the, add one of these to one of the word lists, and call a C function, and that word, if you recompile, that word will be in the dictionary. If you happen to have a word that needs to use other characters like a bang, then you'll need to use X, and then you just make up a symbol. It doesn't matter what it is as long as it's unique for this symbol. And so there's a couple of convenience macros in there. If you want to push something onto the stack, you just use push. And then if you want to access the state of the stack, there are so the Arduino build is underneath doing C++, so it's a little bit fussy about typecasts. So I've got some predefined words for the stack positions, or predefined variables that will, or macros rather, that will reference different stack positions as a number, as a character pointer, as a byte pointer, as a void pointer, and so on. And if worse comes to worse, you can cast to those. So for example, if you had some function like send message that takes a string and a code, you would give it a name. If in this case, because there's a dash, you needed to have it as an X. You just make up something for this name, and then you can call the function and pass an item one at the 1th position and a number at the 0th position. Now you do actually, if you're going to, one thing I forgot in this line here, you should actually, and I'll fix this in the documentation. You'll also want to drop values from the stack, and there's a macro to do that. If you just do drop. Or you can do drop n to drop n elements. Another example, if you had if you wanted to set the top value of the stack, you can do that based on the return value. The key thing is that you need to rebalance the 4th stack based on what you've called. Referencing these variables doesn't actually change the depth of the stack. You have another option if it's simpler to reason about. You can actually declare variables here, and you can refer to the top item of the stack. If you do words like drop, it will actually change the depth of the stack. So you need to be sure to think about the renumbering as you do that. One other thing you may run into is if you want to have reference to C++ objects, like the web server is a good example to look at if you're trying to add something of that sort. It's useful to define a macro that casts the top of the stack into a pointer to whatever type. And then, for example, here I'm pushing a new one, deleting an existing one, using that macro. And then throughout, when you want to call into a C++ object, you can just use that macro and then refer to the stack position. And then you need to always rebalance your stack at the end. There's also a word nip. A lot of times you end up in a situation where if you have a return value, oh, actually, here's an example. Why did I? Oh, this is a bad example. Imagine if, for example, the parameter you had wanted to pass was actually in the instead. And then if you do find yourself in the situation where you need something reentrant, where you need something to call back into forth, the web server is also a good one to imitate. You'll notice here this web server on takes a callback where one of the parameters, I believe it's this one, is an execution token. And so if you want to do the little dance to call out or to hand a thing to C++ that will later get called back in from an execution token, this is what you'd currently need to do. I'll probably try to wrap this up so it's even more simple to do if you want to do that. Are there any questions? And I see something on the chat. So. And there are tons of libraries that are already pulled in there for like I2C and the SD card, and this is documented on the website. There's support for ESP32 CAM, but if anybody is playing around with that right at this moment, I this morning built and ran and discovered I'd regressed something, so I'll likely fix that shortly. But I'm in the process of making the where is that board? Yeah, there's a variant of the ESP32 that has a camera on the front of it, and there's some support in there for the words related to the camera and being able to read JPEG images from it.
Right. Thank you very much. Are there any questions?
Yes, this is.
I have a little question. Does the block edit use the flash memory?
Yes. So
Okay.
yeah. So it goes to there's in general I'm leaning on there's a sort of a notion of a file system within a bunch of the ESP32 library, the IDF plumbing that ESP Arduino is built on has a file system underneath. By default, the system, the Forth mounts the SPI-FFS flash storage that's in the device. So when you set up your board to burn it, you choose a partitioning size and you choose how much is devoted to the application versus to SPI storage. So it's about the default one, I think, gives about half of the storage to SPI-FS. So you have quite a like a megabyte and change of storage that you can write to. If you do call, there's a word to mount an SD card, and if you mount the SD card, you can use the word use to change where the block storage goes. And there's a file system there, and there's actually also the full typical ANSI Forth file words as well. So the blocks was just for fun.
Okay, thank you.
I have here my camera. I want to share with you. Can you see the? Can you see the image? Yes. Okay. This is a wonderful software that Brad is doing now. I recommend everybody to try it. It's so inexpensive, the ESP32. This is display, so you see the words inside it's running the words. It's difficult for the image because it's so bright. The OLED is so bright. But I set up this interface to the OLED in only 10 minutes. Everybody should try this Forth. It's incredible. I was following all what Brad did online. So I think this is a wonderful chance for beginners to try to learn Forth with a small device that everybody can buy and work with the physics world, not only with programming, but also adding sensors to the ESP32, adding motors. We will hear this from Don. Don is the next with starting Forth. And I think the whole Forth community should open eyes to this interesting platform.
Mm-hmm.
Okay.
Very nice. Are there any additional questions?
Yes, I have a question for Peter. This is Christian. Peter, most of the additions you've done to your Forth little presentation there, was this done in Forth?
Yes.
Or was this done using the built-in
hardware part,
ESP32?
Okay, I understand your question. The great thing about this platform is that we are working inside Arduino. This is the difference. We are not working with assembler. We are not working at byte or bit level. We are working with libraries.
So you're using libraries from Arduino,
Yes.
a version that is compatible with ESP32.
Yes. This was explained by Dr. Ting, the first talk, that it's almost impossible to work today like we did in the past, because these processors, these ESP32 are 4 processors inside this metal case. It's extremely complicated. We cannot, as programmers, as individuals, talk to these guys like we did in the 80s with assembly and so, because we will never end. It's so complicated that it makes any sense. So everybody, all these forts today are done over libraries. You can't write directly to the hardware.
No, I think you answered my question. By using the libraries, you're effectively using the expressive hardware, because the libraries were written for this.
Exactly. By large teams. Who writes these libraries are a lot of people.
Thanks.
Now, one thing about those libraries is they're quite thorough in accessing all the hardware, so that if you had to do that yourself, you'd be spending many, many months trying to get that worked out. So in this case, I approve of the C library because they're rather limited in scope. How to access the Wi-Fi, how to turn it off, and so on, not trying to solve all the world's problems in one shot.
I will say I am a little bit ambivalent about some of them. One of the things that I've already run into on this board, you would think that with 4 megabytes of flash that it would be plenty of room, but the Bluetooth library is huge. The C library takes on the order of a megabyte of space, and it's large enough that the default partitioning size, when I have my fourth and the other, a bunch of the other interesting libraries that I would like to have by default, does not fit within the default partition. It will fit if you change the partitioning size or there's a feature by default on Arduino for over-the-air update, which is not a good fit for the way our fourth is built anyways. So I'm deeply ambivalent. There's no reason that the Bluetooth stack should be that big, given what's in that protocol. I have guesses as to why. I mean, the Bluetooth protocol is layers of compatibility where you have to be compatible with every single version of it.
Right.
But even then, like it's huge. So I will say that this situation where we're dependent on a stack of libraries is brittle and unfortunate. But it is I think as others have pointed out, sort of.
I will add another idea. We are talking about this with many of the guys from SVFIC, with Don, with Dr. Ting, with Brad, with all of you in the FORTH2020 Facebook. Forth is much easier than MicroPython. Everybody is programming in the maker community with MicroPython now because they don't know that Forth exists. Not because MicroPython is better than Forth. And so our mission should be make Forth return to his position. Because
sorry, Peter, may I?
Yeah.
One moment. I've been in contact with the local hackers community around here, and they asked me to tell some stories about building robots and building low power applications. But when I used the word Forth, they laughed. And they said, you can tell anything here, but never use the word Forth.
Yeah,
so
it's real. I tell this Don. I talk this with Don.
Yeah. They rather use MicroPython and the libraries.
William, but my name is Peter Forth.
I know.
And if people laugh on me, I will laugh on them. Because we are now, the ball is with us, not with them. We are back. Forth is back. You can bet.
Yeah.
You must be in our team.
Peter, may I add something to that?
Yes,
because
please,
I'm
please.
currently working with the SDK of the Raspberry Pico. And that is interesting because it's if you want to unleash the full power of that, you need C++. And what they have? They have a giant library. And if you and I've worked with it now. If you compile Blink, that's 5 lines of code, and it pulls in all of the libraries, hundreds of lines, and then it has a very complicated program to remove all subroutines that are not needed, and then you end with a very small Blink. And it is interesting, everybody knows make. They use CMake to make a makefile of hundreds of lines for this stupid Blink program. And we must be able to beat that with Forth. We must. And of course, it takes months to rewrite those libraries. But we are with hundreds of Forth programmers. And if I need only, for instance, a piece of code for a blinking LEDs, so simple I/O, then I can make a block with that code. And if I make that block, nobody else needs to make that block again. And if we build these libraries slowly but steadily, we can arrive at the point where we can do what C++ can do and what MicroPython cannot do with Forth. And then they will not laugh at us again.
I agree, Albert. We must look, I have now a picture of all of us here. I will do a print screen because I am very happy to have the people of Netherlands, who I admire so much, together with SVF guys from California. We have here Brad Nelson at my side, at my picture, Don Golding, and Dr. Ting. And they have made a wonderful force. And you are a wonderful community in Netherlands. You have so much experience. William is, for me, fantastic. I follow all his videos. I love William. I passed all these videos to Don the other day and told him, Don, we must enter in contact with William, with Albert, with all the guys in Netherlands, and we must make a team together and bring Forth back because we have the chance. Okay. There is nothing better, in my opinion. Sorry if I am wrong, correct me, but in my opinion, I program much faster in Forth a maker application. I will demonstrate this in the next weeks. I will make, for example, temperature, pressure, stepper motor, LED, relay, OLED. I am inspired, and I told this to Don and Dr. Ting, on William Knob Forth and on William Eagle page. It's a wonderful, simple to understand Forth project. I love that.
I do have one question for Brad. Brad, you still there?
Yes.
Yeah, so right now we're using the Arduino IDE, and I totally get that. But at some point, we're going to be able to just use a terminal program and talk to this guy and get rid of the Arduino, right? At some point.
I think that the critical question will be we would have to either be able to sort of canonicalize the image that we produce, and then we're sort of still behind the scenes dependent on it. We may be able to pickle that up so that folks don't need that tool and can build from a binary that we distribute.
You're muted, Don.
I lost you there, Don.
Oh, sorry about that. So what I'm saying is, after it's I have no problem using the tool to program, you know, a brand new board. My question is that once the fourth is programmed into it and you're only doing fourth development, that you can just use a serial, you know, a serial program, and now it's just a fourth computer.
Yeah, that's the intention. I think that I think the point about libraries is one of these sort of frustrating ones where I think that if we have a critical mass of stuff, like there is a point where, like, take the OLED stuff, for example, we could, there's enough low-level plumbing to write the OLED library on top of digital pins, for example. But because Peter wanted to pull in an OLED library that was written in C, he had to rebuild. So we have that problem, that so long as we're dependent on libraries, you know, if we want to, you know, if we want to benefit from the libraries that folks have written in C, we keep having to go back to the tool and rebuild a fourth with additional words pulled in.
Well, that, to me, that's no problem whatsoever. That's fine. You know, whenever we want to pull in a new C library, we have to go back to the Arduino tool. But once we build our core fourth system, then it becomes, we're just using a terminal on our PC at some point, just like a normal, you know, it's just like a magic fourth board sitting out there on a serial port.
Yep.
You know, longer term. Right now, we're kind of building the system and playing around with it, and you know, we're going to need the Arduino interface. But after you get to the point where you pulled in all the C libraries that you need, then you can sever that and you can just use it as a, you know, standalone force system. So, you know, to me, this is the best of both worlds.
Well,
I will say one of the reasons that
yeah. Sorry.
Yeah.
Right.
One of my ideas is that just to copy a certain library piece of C is needed. Within CI fourth, and it works brilliantly. You can have a very small kernel, and then with a block file of just 256 kilobytes, you have a tremendous library available for everything.
Also, I would like to hint.
That's what a certain piece of C load the block as needed very much within kernel, and then 60.
He's gone.
Not sure I got all of that, but perhaps
yeah. I think he's hinting at the CI force library that is a block file, and you can use the word want to actually ask for specific implementations, and then it just loads in the appropriate things. I also want to hint at the website, FORTH2020, which is a library collection. And it's a platform that is run by Gerald Wodny in Austria. And it's a very nice way to collect things. And he's about to also implement drivers for these. So instead of going there and downloading the files from the website, you can load them from within your FORTH system, which is rather nice if you have an internet connection. So if you want to, I can talk about the FORTH.net and how it works, maybe at the next meeting, so that everyone is on the track. So that's a platform for sharing FORTH libraries, similar to what the JavaScript people have with the Network Packet Manager NPM.
Ulrich, how do you see this ESP32 FORTH for the German community, or as professor? You are a professor, no?
Yeah, right.
Do you think there are possibilities for German schools to learn ESP32 FORTH, this kind of FORTH, a simple one?
Yeah, because the hardware is so simple, and if you have kids, you can go there, and if the kids get contact with that, they will easily grasp this and know about this. So that's possible. The issue with teachers is that they know, at least in Germany, they are not really very skilled. So you have to teach the teachers first so that they can work, and you have to supply background support. So if the teachers can't continue, then they have some place to ask and get advice from there. Otherwise, I think it's an interesting thing.
Because German FIG had the FORTH eFORTH project, no? It was very nice also. Yeah, and we have lots of courses also where we were with Arduino, and I think it was AM4 as the core, but today with the ESPs being cheaper than the Arduino boards, it's probably the right way to go. Yeah, but well, we need to see. Yeah, I think that's reasonable to go there, and it's yeah, the bring up is very easy, which was always an issue with AM4, that you have to reflash the bootloader, and then you were non-Arduino but AM4 and so on. Yeah, so I think it's an interesting topic, an interesting system to look at.
I have a lot of experience in education. I sold over 2,000 Whiskers robots in 10 years. And they were sold by the number 2 and number 3 top distributors in tech ed. And the next meeting, I'm going to go over the curriculum and that robot, because this meeting, I'm going to kind of wrap up the basics of FORTH so people can start playing with the board, with the boards. And then we're going to start, like Peter FORTH is going to show some, real hardware code and implementation, and I'm going to kind of switch gears a little bit and because I am also working on a new robot board, which is forever, but I'm going to get it done. Dr. Tingle is beating on me to get it finished, but anyway, so when you have an intelligent robot and you can teach a student the art of programming in 10 hours time. That's what we did with Whiskers. And it was fun. And somebody mentioned something about earlier on, and it kind of tweaked me a little bit, that I wanted to respond to it. He was absolutely right. He says you have to get kids to get emotional, tie into the project. And there's nothing more emotionally fun for a kid than to make a robot do something, and especially an intelligent robot that makes up his own mind. My robots make the decision, not the programmer. And I hopefully I have one Whiskers and I'll have to put it back together again and maybe show them to you. But it was a very successful program. Probably 50 to 100,000 students went through and learned the art of programming with Whiskers, until finally the big company got in there and took it away from me, which is Legos, right? So, and what do the students learn with Legos? They learn to snap blocks together. So, with my robot, they literally learn programming. They learn how to use loops. They learn about variables and constants and defining words. They defined words. They were fourth programmers in 10 hours.
Hmm. Okay. Right. So thank you very much again, Brett. And I think it's an interesting system, and I can encourage everyone to go to this website that has been posted in the chat. Have a look, grab your ESP board that you normally have lying around anyways, and put ESP32 forth on it and try it out. And then yeah, we can build up a community, which I believe is the first thing, so that Brad is doing these things, Ting picks it up and does bring his lessons in, so that's all great. But we of course need to have more and more people to look at it and be familiar with it, and then we can decide how to bring it in the different countries. Right. So yeah, thanks again. Are there any questions to Brad? We started discussing already. So Brad, thanks again for this nice talk. And then I would say we had the coffee break already, and which means we have the welcomes. So the salutation of the group, which is just say hello, who you are and what your interests are. And so we have 4 persons on that list. And yeah, the first one is Wouter van Ortmessen. So are you with us? And can you say a little bit about yourself and introduce yourself? So, Wouter van Ortmessen.
Ulrich, many of the guys are not in the Zoom anymore.
I didn't check. So yeah, we have Ashley Faneyo.
It's not here. No.
Yeah, Su Yang Sheng and Dimitri Pinado.
Su Yang is in a competition of robots.
Okay. So any one of you are still there and want to talk a little bit? Who else who is in the conference still and want to introduce himself? That's perfectly fine and welcome.
Okay.
Can I ask Brad a quick question?
Sure.
I'm wondering if your new Forth has a way, like Don was talking, disabling the web server and flipping over to terminal use. Is that possible right now?
It actually starts in the terminal. It starts in the serial port, and you flip it the other way. And so you have to either you can configure it to boot up and start the web terminal, but you can also just start in the serial terminal. And in fact, that's the default.
Okay. Thank you.
Okay, gentlemen.
Yeah. Maybe
This is Christian.
Maybe I can.
So who's? That's probably Albert.
Yeah, I have a question to Brett also about his blocks editor. Is he using his block editor to develop software directly on the ESP?
I'm not particularly using it actively for development. I mean, it does it on the ESP and it stores to the ESP's internal flash. So in that sense, but I'm not actively developing the system from within the system. No. Perhaps someday.
Okay, I wondered because retyping each line is kind of cumbersome.
Yeah, it will. So if you store to the block editor, it will retain it. As the key thing though is you need to make sure you don't repartition the device. If you repartition the device, it will lose the contents of the SPI storage. If you have you can attach an SSD drive device to the appropriate pins. Then you can actually store on SSD, or also the ESP CAM, a 32 CAM, has a flash drive built in, and then you can store to that as well. So that's working. And then you can actually eject. So the ESP32 CAM has like a little itty bitty flash card slot. So.
All right. So Christian, you had something to say.
I think he left.
Oh, then he left. Okay. Yeah, right. So maybe he just wanted to say bye. Who knows? Right. So I think then we're done with Brad's talk, and next on the agenda is Don Golding, or do we want to have another break? Yeah, there's Christian again.
Where is he?
Yeah,
Christian.
Go ahead. Say what you wanted to say.
Okay, so probably I'm a new face in this group. Before, I used to watch you when Peter published the recording of the meetings. So I'll introduce myself. My name is Christian Hintz. I'm from Victoriaville, Quebec, in between Montreal and Quebec City. And as a professional, I was an electronic technician in computer science. Basically, I spent my life installing and maintaining computers. And I never understood why they worked. So FORTH will probably help me better understand the software part of computers. And for the hardware part, I think I'm going to have to find a physicist to explain to me what is a semiconductor and why it works. I use transistors and microprocessors, and all my life I use basically semiconductors, and I never understood why it works. So I'm here, I'm still curious, and FORTH is part of my curiosity.
Christian, you are doing great in the Facebook page. We love you here.
Okay, well,
Yeah, thank you.
I love to have a few people to share my interest while I'm stuck in the house here in Quebec in confinement.
Oh yeah.
But we will survive.
We will survive. I think so. Yeah, you're welcome. Thanks for having you here. Okay, great. Then I would say we're ready for Don Talks. Don's talk. Sorry. Don, you're prepared to give your starting FORTH lesson?
Yep, I am.
Then please go ahead.
Okay, let's see. Okay, you guys see my screen okay?
Yep.
Okay, so we're going to start with radix words. So with FORTH, you can change the base, the number base, as you need it. The basic ones are decimal, hex, and binary. So in the little black box there, I did a screen capture. I took my code, or I interactively typed into FORTH. So decimal 15, and then I said binary dot, and remember dot means display, and then it shows me the binary equivalent of 15, and FORTH returns okay. then I say binary 111 decimal space 50 dot, which is display, and it shows me 15. Binary four ones again, so that's binary, and then hex display dot is display, and that's an F. So now I want to ask you guys, so what radix am I in now after running that code? If I typed in 15 right now, would I get 15 decimal?
You're still in hex mode.
Yeah, you're right. You're still in hex. So newbies to fourth, make sure that you type in decimal. If you get some weird answers, maybe you're in the hex mode, or if you're in the binary mode, fourth is going to like say, what? I don't know that number. I don't know 15 because I'm looking for all ones and zeros. So I have some words here that I developed. One of the things we want to do as we go along is develop some tools that are handy. So here's a definition of a word. I want to talk a couple of things. So you'll notice that the source code that many of the people in the group, they put everything on one line. Now, that's great for making compact code. And if you're storing code in the blocks in the ESP32 and you use tons of white space, you're throwing away a lot of memory. So that's kind of where a lot of the old fourth programmers and they take great pride in the fewest number of lines to solve a problem. But when I'm teaching for it, I use what's called pretty printing. And so one thing on a line, so one function on a line, and then also I try to document that. So you'll see that as the difference. But if you take this code and you come over here, so I just copied and pasted it. Oh, and by the way, let's do this first for newbies. Okay, I just closed that out. This is really important. I'm trying to get to the top of the screen there. Let's see. Get this thing out of the way. Oh, there we go. You want to go into tools and you want to make sure that you have the serial set to COM18, or I mean, to whatever your COM port is. So I've seen that where it doesn't come up right away. Sometimes I have to go into device manager and play with Windows a little bit to get it to work. So anyway, this is the interactive terminal program. So we just defined that word. And let me come up back over here. So now I have decimal to hex. So let's say I say 12. I'm just going to paste that in. So 12 is actually C in hex. So this little word here just became a tool for me. I am, and this is the art of programming in fourth. You make lots of words that do one thing. They're not complicated. They're simple words because they're reusable. So now, now I've just added to fourth. People were talking about, well, fourth is so primitive, but it's so easy to add this kind of stuff, and now it becomes part of your fourth system. So if I save this, or maybe I keep a file, like right here, I have a text file of all the different words that I have I programmed in just for today, as an example, you can take little pieces of it and you can, you know, copy and paste it in, or you can take a whole bunch of them and copy and paste them in. So what we want to do with Forth is a meta language. It is a language to create a new language for your application. You're not writing code, you're creating a language. Think of coding that way. Think of, you want to talk to your computer using your voice and give it commands. So when you create the names of your words, try to use English. Don't use computerese. You know, how would someone who never saw your code before want to talk to your computer using their voice and command it to run your little widget? Maybe it's a robot, maybe it's your smart home, whatever. So when you're coding, try to keep it as English as possible, and try to keep the words, they only do one thing at a time. So originally we didn't have binary defined, so this is the definition of binary. You can see that you could, binary is simply base 2, right? Well, you could have base 8, which is octal. You could create any base you want. You could have base 3. I don't know what that would be called, but you could create any, you know, you could have Forth work in any base that you want just by putting a number into base. Now make sure that you use decimal because that's what you're thinking. So just to make sure that you're not in the hex mode or some other base, always type in decimal before, you know, if you're not sure. So we have that. So here's one, decimal to binary. So let me, okay, and because I'm lazy, I'm just going to copy and paste this in. So I want to type in, okay, decimal, let's say 9 decimal to binary. So that's going to be, that's the binary equivalent. I just added a new capability to my Forth system. I'm sitting here and I'm an embedded programmer, and I want to, you know, what was the hex value of 15, or I want to, maybe I'm reading the data sheet and all the addresses are in hex and I want them in decimal or binary or whatever. So I'm making these little words in Forth as tools, and they help me bring up, they help me write in. So here's another one. So this one is hex to binary. It's kind of a useful thing. So let's say I want to do an F, hex to binary. Let's see. Oh, okay. You have to put the radix first. So hex F. All right, this worked before. What? Let's see what's going on here. Hex F. Hex to binary. There's something wrong with my code there. All right, I'm going to move on. Anyway, that was working. Decimal. So anyway, let me go through the code. Okay, so I want to save base. So I fetch base, I duplicate it. I put 16 on the stack. So 16 is going to be the top level word. I'm going to say, is it equal? Because if I'm already in base 16, then if 16 equals 16, that's true. And I've consumed the top of the stack, which is 16, and the second item is 16 because I did a dupe. And then after I do a 16 equal, it's going to be 16 is the second item and true or false is the top item. That feeds if, and then I do a swap, and then I display it in binary, and then I put the base back. Because I had said binary here, I need to put base back to where it used to be. That's why I duplicated it up here. And now I store that in base. Now, if let's say I'm in decimal, the 16 equals will be false. And now I'm going to do the else, and I drop everything off the stack. And then I tell the user, hey, you need to be in hex before this is going to work. So let's try the next one. Okay. So we're going to say binary 1001, or I just added another one there. Take this, and we're just gonna print it. I had all this stuff working yesterday. What the hell? Anyway, so this is a similar sort of thing here. So I'm fetching the base, I'm duplicating it, I'm checking to see if it's actually in the binary base mode equals, and if it's true, then I'll swap it, and then I'll display it in hex, and then I'll restore the base. If it's not, it's going to tell the user that you're in the wrong thing. So not every time you want to demonstrate a project when you're got a bunch of people watching, this can happen.
I think you have to. Sorry, I think you have to start your FORTH compiler because it probably thinks it has missed one semicolon, so it's not ended in the wrong state.
That's a good guess. Maybe hit a semicolon or something. It might also help to hit type by and reboot the thing.
Type by?
By, yeah.
Okay.
Wait, why is it? That's weird. Oh yeah, no, you're clearly not in. Hit semicolon and then by. It thinks you're in interpret mode somehow. It's in a weird state, Don. Hit the reset button. I don't know what you hit the physical. There you go. Okay.
All right, so let's go back to the other one and see if it works, because this stuff did work.
I'm not sure what extra thing you entered there, but
okay.
I think one of the cut and paste did not have the final semicolon.
Oh, I did it again. There's a semicolon right there. If I'm wondering if there may be if you copy and paste, it's going too fast and then it's not interpreting everything. Is that a possibility?
The other thing is, I wonder if it's your quotation marks. If there can be an encoding issue between a lot of. That might.
You know what? Okay. Let me go, instead of going in, I was using the code that's actually in
you're
there.
Probably in the bad state now, Don, but I would say reboot the board, hit, and
okay.
Then take from there. Because I bet a lot of products that use Unicode stuff with quotes, they make them, they switch them to like inward and outward facing quotes, and so it's not the same ASCII character. So that might
Okay.
be.
Yeah, that happened to me out of a PowerPoint as well. That's probably what it is.
Okay. Oh, the other thing was I was copy and pasting out of my notepad file. So I'm going to stop copy and pasting out of this. There may be some hidden code inside of, you know, characters in there or something. So, all right. So we'll get back to it. Let's see.
Yeah, I think you're in the bad state again. You probably need to reboot it, maybe semicolon by or something, and or hit power cycle the board if you've got a reset button.
I just power cycled it.
Okay. No, but after you just you've pasted the bad character in there is why I'm worried.
Yeah. Okay. I'm gonna reopen the terminal.
I like the web application, the web IDE.
Don, this is actually valuable to newbies because we run into these things all the time and it confuses us.
Yeah, this is interesting.
Now, I had a similar problem before with my Motorola 68,000 board, and it turned out that the terminal program was doing filtering of the data.
Really?
So
Don,
it was taking out my semicolon.
Don, the fact that the buy isn't working means you're still in the bad state. You need to semicolon base buy, and that might get you out. Or
Wow, that rebooted when I
Just
typed it in.
try to paste it in a text file first.
Okay.
We had it, this morning we had it, and there were spaces inside
the
the
fact that
text.
you're typing buy and it's not rebooting the board is not a good
Okay.
sign.
Okay, well, it looks like it did it right now. So let's try it this way. Hex. Let's make it FF. Let's just make it F. Okay, and now it's working. So you see that it's 111. Well, what if we had some really crazy hex value, you know, like that? Yeah, AF134. So there it is. There's your answer. So it took this really crazy hex value and it produced the binaries. So let's just say that you're reading a data sheet and it tells you that the pin address, the pins are memory addressed. So you can use these words, and you know it says that you need to set line, it's 8-bit wide, and you want to set line 6 and line 3 1 to make your motor run or something like that. These words are very handy for that kind of stuff. So for newbies, I think this is some good words for them. It also shows coding style. So let's go ahead and so I need to make sure that I'm in decimal. I'm going to type in decimal, and then I'm going to do my paste. And now let's say this is binary. So let's just say you read it on the data sheet. You need to put a 1 0 0 1 1 0 1 out, and you want to know what the hex value is of that. Okay, now you see the error message, you must be in binary mode. It's because I didn't type in binary first. So it's actually working. So I read on the data sheet, I want to have these lines set. Everywhere there's a 1, I'll get a high in the output. So that's a 6C. So what this shows you, you new guys, you can extend forth. You can make it smarter and smarter as you write words and you're extending forth. You're extending to the language. You can't extend in, well, the only way you can extend C is use the pound define, right? A pound define, you can use macros and you can create things that the compiler can understand, but all it's doing is replacing that source after the pound defined. You know, you have a name, and then whatever the source following that is replaced in the code. What you're doing with forth is you're actually adding to the language. You're making it more powerful. So binary to decimal, I got a word for that. So make sure I'm in decimal mode. All right, I'll paste it. And now we're gonna go, we're gonna turn a binary number, like let's say you're reading a data sheet and you want certain IOs to be set. So we have to give it binary. Let's just say I just want the first one. This is actually the top one. So this is going to be bit position number 8. That's 128. So these are nice little words for newbies to play with. Okay, here's another word. Okay, make sure I'm in decimal because I'm only doing this because I'm playing with the radix. Normally he defaults to decimal. So now I can say you know, 10 spaces. And let's just say I do 65 emit, which is an A. So you can see I got 10 spaces here. So this is how you extend the language. Let's say I'm writing my little code. Damn, you know, I'd like to see the ASCII table. There's your ASCII table right there. So it just produced. Now, let's look at the code. If you look at the ASCII table, these are the printable characters, 127 to 31. So I'm going to get back into my my PowerPoint here, and we'll get going here. Present from current slide. So I showed you these things. And these are, the black box is where I actually used Gforth for, if it's black, I use Gforth to test the word. If it's white, I actually did a screen capture of the ESP32. This code can be used on any forth. So it's not specific to our forth. So these are kind of the ways that we can extend the language. And I showed you those are some good examples of programming. So now we're going to talk about loops, the do loop. We have several different types of loops in forth. Do loop was the very first loop that was created when Chuck first designed forth. And then we've added some other types of loops, and I'll go through the other two. I have Dr. Ting's for next loop as well in here. So with a do loop, you put your high number on. So let's just say if you're going to do 10 things, you'd say 10 space 1 space do. So that means that you're going to go 10 iterations through the loop. You're counting down to 1, right? Then we say do. That's the start of the loop. You put whatever statements that you want to execute. I is the index of the loop. So you know, every time it goes through the loop, it, let's just say it's counting from, you know, 10 to 1. So the first time through, you know, it would be 10, and then 9, 8, 7, 6, 5, 4. Maybe you want to do something with that. And so you can use the I. You can put two numbers. Let's just say that you're testing a port. You could have a port number or something like that, and then maybe a binary or a hex value, and you're going to compare those to see if they're the same. If they're the same, you put the statements of the things that you want to do. Maybe it's turning a doorbell on, or a motor, or whatever. Leave allows you to exit the loop, and then of course completes the if statement. Move that up there. And then we can have statements in here. So if this fails in here, execution is going. Please mute your microphones. We're recording this. We want to have it clean for people to watch. Okay, then after the then statement, if this is false, then it's going to drop down and it's going to run whatever statements you want if this is false. And then we it loops again. So we already talked about this. So this is dot spaces. So this is basically going to, you put a number on the stack, maybe 10 spaces, 5 spaces. I'm going to need this word when I do my ASCII table, because I want to put the number on the left-hand side. I want to have 5 spaces, and then I want to display the actual letter that is that's in the ASCII table. So I needed a word called spaces. Here again, we're extending forth. We're making it smarter. For newbies, this is a really important word. The stack is probably the hardest thing to learn in fourth. It's not too bad, but you know, you're trying to think of what's on the stack and you know, and all that sort of thing. Once you finish a colon definition, you don't want to be leaving things on the stack. This is how your system can just blow up. Is you go through a loop, and every time you iterate through that loop, maybe you're leaving some data on the stack, and your loop is you know, 1024. You know, it's going through 1,000 times. You're going to blow up the machine. So if you put this word, what it does is depth returns the number of items that are on the stack. And then here we have another do loop example. So it's going to go, if you have 4 items on the stack, depth will return 4, 0 do, and I'm going to drop them. So when you're learning fourth, clear stack is a very useful word. You might want to put it, what you ought to do is do a .s. .s means display the stack contents when you're testing your words, and make sure you're not leaving stuff on the stack. But if you have if-then statements, you know, you'd have to test the if-then statements too. So now factoring code is really important in fourth. So instead of writing, like in C, you might write this big old function that does all this stuff. And I'll tell you, even in C coding, I factor my code. I have lots of functions in my C code. Each function should do one thing. It shouldn't do multiple things. So for example, this is the code for ASCII table, right? Now I could have put, you know, 5 space is an actual fourth word. I could put space, 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 or I could put a loop in here, right? I could put 50 do space loop, I could put that right in here. Well, that's not factoring my code. I'm making this thing big and you know, and more complicated. Isn't it nice? If I say 5 spaces, that's very readable code. That's another thing about factoring. You should always factor your code. It actually makes it more readable for people. If you have all these nested do loops in there, it gets to be hard to figure out what it's doing. So always factor your code. What we want to do with Forth is we don't want to program. What we want to do is we want to write a custom language for your application. Like I said before, think in terms of teaching your 14-year-old to control your system. You know, he wants to use English words. So create a language. Try to think about, you're going to use a voice recognition front end. There's an Arduino board out there. It's really cool for $50 that does voice to text. You can use that, buy that board, put it on in front of your ESP32, and now you can talk to it. There is nothing better than Forth because you don't have to write any code to interface to it. You hook up the serial cable to it, and now it's driving Forth, the interpreter in Forth, and whatever word you have, you know, you have defined will be executed as you talk. I did this once with one of my robots. Is I created a robot I could talk to back in is the end of the 90s, and that's how I did it. And there was no code to allow me to use my voice to command my robot. So that's what you want to do. Write a custom language. Try to make it as English as possible. Don't just write programs. Short, simple words are better than long, complicated ones. If your word definition is complex, rethink the problem. How would you like to talk? How would you talk to your computer? So always think of that when you're writing Forth words. Imagine you're talking to your computer, because don't we want to get to like Star Trek? Computer, go to warp speed. You know, that should be real code in your application. It shouldn't be computer port 9, you know, send command of 14, blah blah blah. You know, it should, you know, make it big picture. I want to go to warp speed. Begin until. So this is another loop that we have in Forth. So begin starts the loop. We put our statements in there. We have to do some sort of logical test. So let's just say I said 2 greater than, that's going to be false, right? And that means until it's going to keep looping if it's false. If I said 3 greater than, then that's going to be true, and that's going to feed until, and then it's going to exit the loop. So here's an example of another useful word. So what we're going to do is we're going to copy this, and I won't have to type decimal from now on because I'm not using my radix words, but I'm just doing that to make sure. Okay, so wait for any key, and I just put a dash until because I'm implementing this using the until method. You don't have to put that there. I'm just doing it so that I could have different words doing the same thing. So now we're going to execute that. Now you notice that it's waiting. Okay, now it says okay. So it was, because there was no okay there, it was waiting for me to do an input. So if I do a .s, let's see. Okay. Oh, key until consumed key. So that's right. Stack is correct. Let's see. Now this one, use a little different word in forth. So what key does, key will stop execution and pause. It won't go any further until you type in a key at the keyboard. Well, sometimes you want to just see if there's something at the keyboard. So this, we use key question mark. So now this one, it's not going to stop. And okay, now let's see, where's the next one? Okay, so the next one is begin until, I think I'm gonna leave it like this. You guys can see it okay, right? So begin again is an infinite loop. You have to break out of it, otherwise it'll go on forever. So you type in begin. This is always in a colon statement. You know, it needs to be in a word. It's not interactive. And then you have your statements that you want to do. And then you have to have an if then in the middle of it. And you use a word called exit. Exit breaks you out of the loop. And you can have statements, you know, after it. If this is false, then you can have statements after the again. So this is how you would maybe blink an LED using a begin and begin again. You might test for a keyboard entry, or you might test for a switch. You know, somebody asked for, I actually implemented the doorbell program in the talk today, and we're going to look at that. So begin again is another way of looping and forth. So here's an example of it, and I should have it over here. I thought I did. I'm gonna see if I can do this again. I know what I'll do. I'll put it over here, because Notepad will take out any word, any crazy characters. Okay. So now I'm going to paste it in there. So this is an example of waiting for a keyboard, a key at the keyboard. You notice it says begin key. So key waits until you press a key. And if you press any key, it's going to exit. It's waiting. You don't see an OK there. And as soon as I press enter, we see OK. So that's an example of an endless loop in forth. Dr. Ting's favorite loop. I knew I had to throw that in there. So, the reason Dr. Ting likes for next loops is because they're really fast. They're when you write the primitive code for next, it's really simple on a microprocessor, and it's very fast. So it's the fastest loop in forth. So here's an example of using a for next loop. So I created a word called test3, and what happens is you have to give it, you know, how many times you want to go through the loop. Now here's the thing about for next. It's counting down to 0. See how it starts at 9 and goes to 0? When I told it to go 10, right? It's a quirk with for next. So if I really want it to go 10, I have to subtract 1, or I would put a 9 here. You can put a 9 here and not subtract 1. So just know if you use a for next loop, it's going to go one extra time than you're telling it here through the loop. So just, you know, mentally subtract one, or this is a -1, and this is a word in fourth, which just subtracts a 1 from the top of the stack. So now for next, so here I can use the iteration of the loop. So the first time through the loop, you notice how it's counting down. So the first time it starts at 9 and it outputs a J. So I space, so I get a space in there, and then dot, so that gives me the 9. So the first space is between the edge here and the 9. The second space is this space in here. And then I use I again. Now 65, remember our ASCII table, 65 is A in ASCII. So I'm going to add the iteration of the loop, which first time through the loop is going to be 9, to 65, which would give me what, 74. And then I'm going to admit, so 74, if you look up in an ASCII table, 74 is going to be a J. And the next time through the loop, it's going to be an 8. That's going to be an I. You know, it's going backwards in the alphabet, right? So this is Dr. Ting's favorite loop. We also have a word called C. So what C does, it decompiles your word. So I define a word like this. I define this word, let's see, let's go back to, okay, so this is the code that we had before, right? And if I say C and the name of my code, which is this up here, C will decompile the code and say, okay, well, this is the name, right? It doesn't decompile everything perfectly, so it didn't catch the begin, but it did catch the key. So it's kind of a debugging word that's kind of useful at times. And that's inner fourth. So if I say C, I'm a shitty typer, so I'm going to do copy and paste. So there, right there, we can see that it decompiled the code. Okay. The doorbell application. Okay. So we had a request from one of the newbies. How would you do a doorbell? So I'm going to, we're going to start talking about hardware next month. So right now I'm just going to admit, this is basically the star character. So you'd replace this code with toggling or, you know, controlling a speaker. So your speaker code would go in there, like Dr. Ting's code, you know, for making tones and such. And I know that Brad has got some of these words built in. I haven't played with them yet, and maybe Brad can chime in and tell us what how to use those words. He's got some of that stuff built in, but let's just we're going to do it. We're going to simulate it. So I have it right here. Okay. So I'm going to type that in. So if I run play chime, see how it put out 5? It put out 5 stars, which is what I told it to. 42 is, remember our ASCII table word? I type in my .ASCII table and it tells me that star is 42. So that's where I got that number from. Or you could look it up online, but why not have it built into Forth? So now this is an example of factoring your code. You could put this code in right here, right? But see, I have made a word. I could use this for other things, not just a doorbell. I could use it for maybe my next project. I want to play a chime when the thing is done or something, you know, when it completes a certain operation. This has now become a tool. So like I say, don't write programs, create a language. So now we factored the code. So now it also, notice that it makes this code much easier to read also. If I had all this do loop stuff in there, it'd make it harder to read. So now we're going to take and we're going to copy this. Did it work? Oh, that looks bad. Let's see. Oh, let's see. I got to get that. So let me copy everything. It's not catching something. Is it okay?
It's on my screen, the comment on the, oh no, it's, never mind.
All right, let's see if it works. This is doorbell. Okay, so it's waiting. What's it doing? It's waiting for a key. So 120, and I hate this. I had a problem with constant, Brad. So normally I would do this. I'd make a constant. So ring bell is actually the R key. So I'm going to press R.
You got your constant flipped on. You got to put the 42 in front of the word constant.
Oh shit! Duh. Okay, so see, it says someone's at the door, and it produced five stars. So 5 stars is our play chime. Oh yeah, you know, I switch in between C and Forth. It's just good. So you notice that it worked. Okay, so that means that it would have rung the bell. So let's try it again. Okay. So the next one is 120 is going to be the X key. I'm out of here. So that there's your doorbell program in Forth right there. Easy, right? And let's see. Okay, we did that. So these are our new links. Brad has set this up, and so if you just want to download the Forth, you type this into your browser, and you will download the zip file and unzip it. And then if you want to look at the entire project, you go here. So let's take a look. So there's a lot of great information that Brad has here. he's got some of the words. We need to expand this list and put all the different words that it knows, but he's got a lot of words here. Over time, this will get expanded out. This is actually will always be the latest version. We are not going to put a rev code as part of the name. So if you want the very latest code, always download the same thing. What we want to do is we want to have it so you can always just type that in to get the latest one. Now, you will see up here, the first line of the code, because you're going to copy and paste. This is the file that that we download. So and you're gonna take that file and you're gonna paste it in here and you're gonna compile it, right? You're gonna press that button up there and upload it. But this will have the latest rev. So if you ever want to know, do I have the latest rev? If you got 7.1, I mean, you got 7.0, and it says on that, we should actually put the rev number. Let's put a rev number out here.
Yeah.
And yeah, so you'll know if this rev number is higher than the one you have, which you can see by the first line. You need to download it again. We wanted to, if we change the rev number in the file itself, it would change the link. So we decided that we're going to put the rev number inside as a first line of the code. If you really are gutsy, you can go over here in GitHub and you can see all the good stuff that Brad's doing. And you're a better man than I am if you understand everything he's doing. I don't know if you guys know this, but Brad is a senior programmer for Google, and he's working on the Android operating system group. And you worked on the Chrome group before that, right?
It's so funny, Don, because one day I told somebody about Brad's knowledge and how much I admire, and I said, Brad works at Google. And the guy answered to me, everybody works at Google.
Yeah, well,
there are all the time stupid answers.
Yeah, well, Brad's a very senior programmer. I've known him for a long time.
Yeah,
he's very humble, but he is top notch.
It's incredible, fantastic.
Yeah, he is really something. So there's my email address if you want to get a hold of me. I want to kind of get into more applications going forward in the class. So not only will I be talking, but we'll have many others. So I am proposing that Peter Forth shows off. He's controlling motors and LEDs, so he can show you actual ESP32 using this Forth, how he controls motors. He'll share with you source code. Dr. Ting will do some more talk on the things that he's doing with it. I think he's got some sound stuff working in ESP32 that would be great if he could share that. And we'll start getting people that are actually making stuff with ESP32 Forth. I want to show you my Whiskers robot and the language that I created as the next meeting. Please, you newcomers, post on our group, say, I'm trying to control a motor. I've downloaded the code and I'm having some trouble with it. I need some help. You have the best Forth programmers on the planet Earth, and probably intergalactic, right here at FORTH2020. So don't be shy. If you need to have a word built, I'm sure someone will volunteer and help you build a word to do something that you want to do in the FORTH2020 group. We have the top fourth programmers in the world here, which is a great thing. Are there any questions?
Dimitri, where are you, Dimitri?
I'm here.
Could
This
you
is-
show
Can you hear
the URL again for the ESP repository?
Sure.
Dimitri, you have probably some questions about robots to done.
Yes, I do. I have a few questions on this. Can you hear me?
Yes.
Okay, I wasn't sure if my microphone was on. Well, yeah, some of the questions I have on this, I'm actually asking for, I know some of these, but I'm asking for benefits of other beginners. So are there any naming conventions for Forth? I noticed that some of the words had a dot before them, for example.
Yeah, so dot is a real word in Forth, and what dot does is it displays the top of the stack. So one of the naming conventions that I personally have, if it's going to display to the terminal, I put a dot in front of it, and that's a naming convention that I have. You know, you could replace that with display, for example. You could make it, you could just type out display instead of dot, but dot tells me that it's a display type word. Anybody else want to chip in on naming conventions in Forth?
I mean, I would say that the question ending in a question mark is frequently an indication that a word returns a flag to the stack. There's a historical convention. A lot of words, if they sort of optionally consume the thing in front of them, they'll put a question mark at the front of the words. You'll see this with words like question do and question do, for example. And frequently setting something will similarly be an exclamation point at the end of the word, but that's not universal.
See, so it's kind of like taking...
And of course there are the conventions about double precision operators. If plus adds to normal numbers, then D plus adds to double precision numbers, and F plus adds to floating point numbers. So the whole floating point library starts with the F letter. That's also...
I think some of that cut out, but it sounds very logical.
Hi, Don, this is Christian.
Yeah.
I remember reading something after a search on Google about naming convention for Forth. And it was an excellent text. I don't remember what it is, but if you search, you'll probably find it. It had something like words ending with colon would be words that define something.
Yep,
Words,
that's a naming convention. Yeah, I use that one. Mm-hmm. So when you...
It had a lot of ending characters like this to signify what it does. And this is a problem with Forth in general. If you look at the list of words, you have no idea what they do unless you understand, you put in there a valid English word or whatever your language is. And it's hard to see the difference between a constant, a variable, an acting word, one that does something. And these conventions would be important to make sense out of the dictionary we look at when we do words. So there would be something good to gain in presenting wording, naming conventions. One comment, and by the way, excellent presentation, and the way that you show your Forth code makes it readable. It's not true that Forth is not readable. It's whichever programmer's experience you have will teach you to make things readable. You have to learn how to be readable.
Yeah, so this is, I've actually been programming in Forth since day one. I took originally I learned I was a hardware guy by the mid 80s. I ran across Forth in like 83. I had a company and I bought Forth because my programmer was programming in assembler. It would take an hour to compile, and it was kind of a textual kind of application. It was an obstetrical computer for doctors. And I said, there's got to be a better way. And I ran across Forth, LMI Forth in Dr. Dobbs' journal. I bought a copy and I gave it to our programmers. Remember, I wasn't a programmer in 83. And they said, and we gave it to one of our programmers. He spent a week with it and said, no, it won't be useful for us. Well, I could have fired the guy because it would have replaced him. I had two programmers and I could have just used one with Forth. I wound up losing the company, and I still had the LMI Forth. And what I did was I took a programming class at a local university. I took Pascal because they didn't teach Forth. I was so intrigued with Forth, I wanted to learn Forth, but there was no classes. So I took Pascal and I learned the Pascal language on the first course. The second course was data structures. And the lady that taught Pascal, taught this it's called pretty printing. And so what you do is you indentation, and these things line up too vertically. It allows you to look at code and really figure out, what's dependent on what. So you know that because this is indented more towards the left, this has to, this is driving this code in here, right? So pretty printing in Forth makes it so much more readable, in my opinion. I've been doing it since day one. When I share my code next time, I'm gonna share real source code for my robot that I spent years developing, and I'm gonna make it open source. But we're gonna go through some of the code. You'll see I do that. I was doing that back in the 90s. It's just the disadvantage of this pretty printing is in our ESP32, if you're going to use the line editor that Brad made, and you're using a ton of block space, all these it would just be an awful. It would use up so much space versus all this could be put on one line, and that's why you see a lot of the old timer Forth people always program on one line because they grew up with blocks, and you could put 10 times the amount of code in a block if you put it on one line at a time versus this way. I mean, this would take up half a block, which is a block is 1,000 characters.
Yeah, and I guess all those spaces are real spaces, not tabs. So they all have to be transmitted one by one when you're...
No, the issue is that when you store it in a block editor, each line is 64 bytes. Is that correct, Brad? Long?
Yeah.
64.
Yeah.
Each line
64.
Is 64.
64.
So
those blocks are the original size of Forth.
Yeah, so this begin that uses only 5 characters is going to use 64. This line's going to use 64. This line's going to use 64. So it burns a lot of this space when you're using blocks. If you're using a text editor, there's no cost at all.
Well, but Don, this is not true.
Okay, tell me why.
Because you and I, and probably Ulrich also, I don't know, Ulrich, did you program in LMY Force?
Yeah, I did. Yeah.
Everybody here who knows a bit of Force programmed with blocks in LMY. And we program it horizontally, not vertically.
You do what?
Horizontal, or in a line. We did not program vertically.
Well, yeah, that's what I'm saying. I'm saying this is a disadvantage of this. It's
But
using
it's
so
only
much memory.
you change the way of writing, nothing else.
All we need
No.
is a preprocessor to remove the spaces except one.
Look,
Yeah,
but in my for example, in my experience, no, I wrote in one block 5 or more words, probably 6 words or so.
sure.
Six functions in C are is giant. 6 functions in C is giant, and in Forth is in less than 1K.
Right, but it's harder to read if this is all on one line.
Yeah.
This is much easier to read and understand. And these people that are coming out of school learning programming, they're learning to program this way. It's called pretty printing. This is what they teach you in school. All the programmers coming out of school learn it this way, not in a line. So one of the things we're trying to do here is we're trying to get more people into Forth. It's when you're using the IDE, pretty printing is fine. You do it in a text editor. There's no cost whatsoever.
Don, there is one cost. It's your ability to see very much code on the screen at a time. Right. One of the reasons I think a lot of Forth programmers are attracted to the horizontal style is that you're capturing one idea on one line, and if anything, the goal is that you're trying to make sure your words your definitions are as small as possible, not just because you're trying to be efficient, but because you're trying to be concise and have some sort of orthogonal ideas that are where each word stands on its own and does as little as possible. The intent is to make them easy to understand. At the point that you've got multiple lines, usually that's a sign that your word is too complex and should be factored into fewer words.
Everything you say is, I totally agree. But when I look at a horizontal line of code, I have to do a lot more deciphering as to what it's doing than if it's in this format. And, we're trying to get more people into Forth, and I'm trying to make it as easy as possible. This is
understood. I do to some extent agree that when it comes to flow control words, that there is some advantage to the indentation. I think that the other sort of stylistic thing, one of the other talks referenced this concept of eliminating flow control. Right, in a perfect world, you try to have as little flow control as possible and compute instead of decide and all of that. So that's another sort of stylistic thing where, I'm imagining that, yes, if you have a complex set of flow control, you definitely want to display it vertically because you'll confuse it. And I sometimes do that in my own programs, but I also try as much as I can to avoid having lots of nested flow control and try to decompose it into sort of independent words.
Yeah, and what the key word here, the key word here is factor your code. Factor your code.
Mm-hmm. Yeah, one of the major contribution of FIG or FIG4 is that it liberated us from the straitjacket of blocks that Chuck Moore imposes on us. Okay, I think blocks, and most of people, Forth programmers, think that blocks and Forth block is Forth, okay, but block is not Forth. Block has nothing to do with Forth.
Right.
Okay. Forth is a language, okay, and the block is a way to store programs at the time with the restriction of disks, okay, and Chuck Moore took advantage of disk storage and tape storages by this mechanism of blocks. But block is not part of Forth. fourth is colon definitions, okay? And any way you can represent colon definition, if it's easy to read, it's a better way. So I think after FEB13, the text file becomes conventional for FORTH programmers. And once we can get rid of the disk, floppy disks, you know, block has no place in FORTH programming. And I think so I really think, you know, the way Don, you presented in the vertical code.
Well, but Dr. Ting, there was an advantage in blocks because it is a way of partition any kind of memory. You can partition even a RAM as a solid disk, as everything. You can partition and you can jump from blocks to blocks. This is very interesting because you can compile only small parts of your code, not the whole file. Because FORTH was an operating system, no? This is the other part.
Yeah. It is an operating system. It's a way of programming, but it's not part of FORTH. Okay?
I understand.
FORTH doesn't have anything to do with blocks. So the text file is just fine.
That is, of course, that
you can structure your files like blocks.
I know.
Write you know, small files like blocks, but you can load them anywhere in any sequence.
For example, I wrote my own Western Digital controller 7022 in the year 85 or so. I had a single board computer. I bought the chip and I wrote my own controller. The data file of that chip was of 500 bytes. So I had each block in the Western Digital controller was two blocks of the Western Digital was one block of FORTH.
Yes.
It was so easy to write a file system using FORTH that it was ready. I had only to use FORTH and I could write files on the disk. So this was amazing for me. And this happened all the time with me with FORTH. I was needing something and the tools were inside FORTH. The answer was inside FORTH.
So one of the things
may I add something? Well, I have much experience with FORTH and they are integral to CI FORTH. And I always write my programs in files, always. But I use blocks for libraries because they are small pieces of program that you need sometimes. That is, of course, true.
So one thing I just want to mention is we're getting back to FORTH being the operating system again with the ESP32. So we have a fixed amount of flash inside there, and if you want to use it efficiently, you should use one-line coding style, because you're packing the block. You can do 6 words in a block. If you did it pretty printing, you might get 1 or 2 words in a block, and you're wasting a ton of space. So when I'm teaching, I think it's easier to understand this way, especially since they teach programming today using pretty printing. When you're actually writing real code and you're going to use the ESP32 as a standalone computer, because remember, FORTH is not only a language, but it's not just a language. It can be an operating system too, which our ESP32 FORTH is also, it has blocks added to it, And I agree with Dr. Ting. Blocks and Forth, you know, Forth isn't blocks, but it's just another example how easy it is to make Forth into whatever you need. You know, and it works on a minimalist system. You know, you're not going to be doing this in C anytime soon.
Oh, don't.
You know.
So I have a confession to make with my block editor. I will say that when I put in a block editor, partially because I started down the road of saying, well, I've got this device and I have a real file system on it. And I want to be able to have an editor that I can interactively edit. And I started to write a full text editor, and then realized, you know, this is a pain. And let me start with a block editor because it's an easy abstraction to bring up on this device, even though there's a file system. Now I have to write an editor that will run within the limitations of the terminal and all of those things. And so I was still drawn back to blocks for that reason. That said, I think I probably will have courage and do a proper text editor. But I agree with Dr. Ting that Forth is not
something. Well, I have much experience with Forth, and they are integral to say Forth. And
yeah, that.
What is?
One more comment, okay.
I always write my programs in files, always.
For Don and for Brad. Okay.
I use blocks for libraries because they are small pieces of program that you need sometimes.
Your internet's pretty bad. But yeah, we get what you're saying. There's nothing wrong with, no one's saying there's anything wrong with it. In a minimalist system, it makes perfect sense. Use blocks and use one line type code.
So
Ulrich, what happens?
Yeah, if there's interest, I can talk next time about soft blocks. That's my approach to screens, and it's the benefit of everything.
That'd be great.
Yeah, so it's very helpful. And I asked Chuck about why is it 16 lines by 64 characters, and he said, well, it was convenient at that time, but that's not at all carved into stone. So you do whatever is appropriate. So today might be larger. And I have flexible screens that are as long and as wide as I want to, and they are stored in text files. And I can talk about that.
That'd be
and
great.
It's very nice.
Ulrich,
yeah, okay.
The other,
the ESP32 got a SPIF system for the flash. Okay, and you should take advantage of that because that SPIF system can take lots of text files. Okay.
Exactly.
And don't get me wrong. I would have. There was a file system there, and my first instinct was, oh, let me write a proper editor for it. The problem is writing a proper text editor that runs on the device is non-trivial for when you're, even if you have a file system. The file system is part of the complexity, but the editor for a non-block-based editor is also complex. That said, I probably will do it because it's nice to have a file system there.
Brad, I wanted to ask you one question. In the web IDE, we have choose the file, and you can load the file.
Yes.
There is no block because I opened Notepad, I wrote my code, and there is no block. You can load the file.
This is true. Yeah, no, this is a good point.
We have both things. We have both. We have blocks and we have no SPIFs. We have both.
This is true. This is true. Yeah. I was drawn to the desire to have the board be standalone, but yeah, you're right that in the web editor, yes, then you have conveniently upload and download.
Your editor is a Notepad. Use Notepad.
Well, actually, I like Brad's. I like a full self-contained. I don't need a computer. But you need a computer for the serial port, you know, terminal.
Still want
Oh, that's funny.
Boy, your internet is bad. Sorry.
Yeah, one.
Maybe type it in the chat.
That is, I just use line feeds in my blocks. Yeah, I just line feeds in my blocks.
Why don't you put on a presentation for us?
30 sectors, but you could use in blocks, and then you could have the.
So I think we have two people that'll present blocks for us for the next meeting.
Yeah, great.
I want another thing from Ulrich.
What? What is it?
Local variables.
Local variables. Why not?
Yeah, longer term, I would like to see that too, because what I envision is FORTH getting more modern. You know, so we always have the core FORTH. You're always building on top of it, but the part we build on top should get closer and closer to a more modern language. And when I say modern, I mean not C. C is not modern. C is 60 years old. It's not modern. Yeah, C++ is a nightmare. You know, I mean, I'm sure there's somebody will disagree with me on that, but anyway, so you know, we want to kind of build a more modern language on top of FORTH, and FORTH becomes like the assembler. You know, you want to build something fast, you want to build so it runs fast, get down, use FORTH. But if you have some application where you can stand the penalty of local variables support, then and it makes it easier to program, well, that's going to make it easier for other people to get into FORTH. Somebody today actually said that isn't FORTH obsolete base. I forget his wording, but he basically said, you know, FORTH is an obscure, obsolete language. I think it's in the chat. And that's the perception that FORTH has out there because, you know, swap drop. It's like, what? You know, why can't I just, you know, put, you know, a bracket and then, you know, put algebra in there? You know, why do I have to go through all this stack manipulation? So if you think about the future of computers, we want to have artificial intelligence. We want to have AI computers. What do they look like? You don't want to have to recompile the whole bloody application when you make one change. Okay, that's C. That's C++. You have this huge application and you make one tiny change. Like I was talking about changing the name buffer in Windows, right? It's a perfect example. You know, I'll probably take days to compile Windows, you know? It's a huge task. In FORTH, it's nothing, you know? Well, that's an advantage. If you have an intelligent machine, it needs to learn incrementally. You're not going to compile its whole brain every time it learns something. So the FORTH architecture is actually the future of computing. If we don't write it in FORTH, somebody's going to write it in C, you know, but this is the architecture they need to get to. They need incremental compilation. They need interactive, because you want to talk to your computer. You can talk to FORTH without any programming at all. None, because it has a built-in
and Don, this is happening now in the maker community. people are inventing forth overseas without knowing that forth exists.
And they'll never get incremental compilation with what they're building, which is a huge deal. You know, and then I didn't even talk about deferred words. So, you know, you can have something that's compiled, and let's just say you have a word, and then you have 100 words above it, and that word maybe it talks to it's a space robot, and it talks to the ground station, and you want to change that word. Well, you don't have to recompile the whole Forth application to change that low-level word. You can use what's called a deferred word. It's really simple to do in Forth, and you actually replace that code that's down below, you know, and you don't have to recompile the whole application. We'll talk about that in the future.
Don, we have here Dimitri. He wants to say something about this. Okay. Please, Dimitri.
This has been one of my experiences in helping a friend with his a programming assignment, programming a robot through Arduino, and each time it's just making these small changes to C code, then clicking the button, wait for it to go, wait for it to load to the robot, set it up, then you know it does something wrong, then you have to go through that loop again, and it's slow. It's slow and just completely unreasonable. So I see the power of Forth in that incremental compilation for developing things, for robotics, because you don't have to wait like that. And I'm sure I can see why people would start trying to develop their own systems for that kind of feedback, because it gets tedious after a while. But yeah, I'd be interested in seeing more of Forth robotics next time, because I've personally never come across it before, but I've heard of it. I've heard of Forth being used for robots, and it seems like you can write readable programs compared to the C. You know, when my friend was writing C code, he would miss out the punctuation, and then you have a compile failure, and then you have to go through and solve the next error and the next one. And I was thinking how much better it would be just to write something that resembles English and have your robot just follow it compared to that. I agree in terms of your vision for Forth.
Well, we're going to go over that. That's my next talk. Is going to be controlling robots, intelligent robots, using Forth, and it's something I designed back in early '90s, and I created many robots. I actually designed and built the very first man-packable robot for the U.S. military, for U.S. Special Forces, before iRobot came out with their PackBot in '97, and it ran Forth. And I'll tell you some stories about that that'll make you chuckle.
Yeah, that sounds great.
So get all your Forth guys, you know, on the Zoom meeting next time, because we're going to be talking robots serious.
Rob Probin is from UK. He's also in the meeting. I don't know if Rob wants to say something. Hello, Rob. Unmute.
Hey, Rob.
Unmute.
Hi, Peter. Hi, everyone. So I guess Peter's been harassing me to do a presentation on this. It's a small robot that was designed by an organisation called UK Mars, which is sort of non-profit organisation to encourage small robotics for line following and for maze solving. So a lot of the people have been involved in sort of the micromouse competitions. And some of the guys are using Forth on this to drive this. So maybe at some point Peter will actually convince me to do a presentation to this group.
Great.
I'll put the link in the chat.
Rob, how about you do it next time, because we can kind of have a robotics theme, or at least sub theme for next time.
Okay,
That'd be great.
Well, at very least, I'll go through some of the basics on this robot, and you know,
that'd be great.
Rob, one of our members is now in the arena fighting with his FORTH robot, Su Yang. No, Su Yang is now trying to kill another robot with FORTH.
Yeah. So yeah, I mean, what we're actually trying to do is get you know, a bunch of different platforms onto this. I mean, typically with Micromouse, for those that know it, it's been running since what, 79 or something. Micromouse has maze solving robots. It's still very big in Japan, for instance. They still got monthly, yearly competitions in the UK and in America and in various other countries in Europe. And we've got quite a few people who are using FORTH as their sort of base language to build it. One of the things, especially with robotics, it's got so many. To build a robot's quite a big steep curve. You know, you need to have some idea of mechanicals, some idea of like gearing, some electronics, some software, and usually for individuals, it's quite a tall thing to put together. So one of the things with this is that you know, we've got a platform so for instance, this particular one we've put a Raspberry Pi on, and then Arduino Nano as a platform. People have been putting different microcontrollers. Originally it was designed just with a Arduino Nano, and people are expanding the number of sort of microcontrollers, and we're hoping they'll expand the number of programming languages up as well. We haven't got a full-fledged implementation of FORTH yet. It's still on our to-do list, but that's definitely something we want to look at. Because the interactivity, I mean, everybody who touches FORTH, even if they don't program FORTH today, my experience has been they tend to make, you know, whatever language they go to, they make their procedures or the functions smaller. They want to incrementally test. So even if they haven't got a native FORTH, they tend to put command lines on things. So you can see people who've used FORTH before, because they've got all these habits that Leo Brody talked about that spreads throughout their programming, you know. It's one of the sort of advantages that people don't see. Languages that have got expandability like FORTH has, and I guess things like Lisp are another one, although that sort of can't go down as far. They've got a different way of thinking about problems. And I think that helps people as well, even if they're not, you know, using FORTH every day. I think it's one of these things that sort of expands your breadth as a engineer, as a developer, in terms of, and people were talking about embedding languages in, and that was, I mean, it's been done for years with FORTH. People have pointed out because it's easy to do and it's very flexible and it gives you a whole bunch of power.
So one of the comments I want to make is, I when I first learned FORTH, I used starting FORTH, and I said, okay, you know, it's a programming language, it's interactive, okay, that's kind of cool. And then I read Thinking FORTH, and my brain just went, holy shit, this is the way you program a computer. And if you look at my C code, it's very FORTH-ish. I have tons of functions with long names that describe, you know, what the software does, and I put them together, and then I'll have a function that does the control stuff, you know, with if then case statements, all that stuff, and like a case statement, it calls one function. There's no code in there. I do it FORTH style. You know, that function in that case statement is defined somewhere else. And so if you want to know what it does, you have to go look at it there. It's not in the control flow stuff that Brad was talking about. So everyone must read Thinking FORTH. You gotta read it. It's just, it will open your mind, and regardless whether you program in FORTH or not, it'll make you a better programmer in any language.
Yeah, I mean, it also makes you miss. I mean, Paul Graham, the Lisper, talks about the fact that Lisp macros have got this, you know, you can expand the language. And once you've been in one of those sort of languages, whether it be FORTH or Lisp, as soon as you get into C, you go, I need a different type of control structure. And you see it in code, C code, all the time, right? The control structures are very limited. You've got no way of changing it. Anyway.
In other languages, they try to do. So C++ tries this with templates, and Rust, for example, has macros as well. So that's a really modern thing, and they are inventing immediate words.
Yeah. Well, I've seen a lot of abuses of C preprocessor macros in my time. And
exactly.
and Barney Strustrup was right. They need to be left of that language because they're just so they haven't got any intelligence in them, the C macros, you know. So people abuse them, and then the compiler doesn't know anything about them, and you've got no way of undoing the tangled web you generate. Whereas in Forth, you know, if you've built a control structure, you can go back and redefine it and make it so that it's maybe less dangerous, you know.
Great does, two most powerful words in Forth.
Oh, Rob, I think you definitely need to present next time. I mean, I'm meant to be presenting, and I don't know half as much as you do.
Thank you. Yeah. So, I mean, yeah. Okay. We'll see what we can do.
You're drafted.
Apparently so. Talk myself into it.
Great. So I'm looking forward to it. Yeah, robotics and Forth are like, you know, peas in a pod. And I will talk a lot about, I built a lot of robots in Forth using Max Forth.
Yeah.
Specifically.
Yeah. So
a couple thousand of them.
One of the people who pulled me into robots a good number of years ago actually was a person who ran his company building robots for education, Swallow Systems. So yeah, I mean and he teaches kids to program with Forth robots. You know, he's got various schools he goes to and arranges after school activities, although not over the last few months because of obvious reasons. But yeah, it's sort of as somebody said, I mean, people want sort of much more immediacy. I mean, what happened in the 70s was, you know, incremental refinement, right? That was a big change in the 70s, versus batch systems, and you know, Forth really suits that incremental refinement methodology.
The words to live by in Forth programming.
In all programming, to be honest, you know, it's difficult to build working systems without a huge amount of upfront analysis, which is only cost effective in places maybe like defense and in certain other areas. Generally, once you've got the basic maths primitives or sorted out, then you really need to build a system that suits users, which means, you know, you're doing it. I mean, we should talk about sort of methodologies at some point, right? Because I mean, what a lot of the people are doing with things like agile development is building in pieces, you know, and that's what Forth is suited for.
I will share my screen very rapidly, very fast. And here you see, this is a C80 controller here, the box. And on the screen here on the computer is Win32 Force. This is a company in UK. David is part of our group.
With the simple teach pad, you can control the robot in joint mode or Cartesian mode. This is the R17HS, a high-speed 6-axis model with a 750mm reach.
Did you know about this guy, Don?
No, it looks great though.
Okay, and he does not want to talk with us. He's part of our group, but this Saturday he's busy. He's a super.
I'd love to hear about that.
He's a super nice guy. David is excellent guy.
We need to draft him. Forth and robotics is, you know, they're just, it's the best. Forth is the best language for robotics. End of story. There's no better language.
And what I like from David, he can tell you with all the words about that, how his customers understand forth programming for robots in 10-15 minutes.
Right.
And after that, they love forth. They absolutely love forth.
My robots were teaching kids with zero programming experience in junior high school tech labs in 10 hours. And they learned the art of programming. They learned about do loops and variables and constants and control statements. And they literally, and it was fun because the robot did, actually my robot was kind of smart. So sometimes it didn't always do what you told it. And I'll get into that later. But yeah, they absolutely loved it. And I can just imagine when they took to their first C course after that. It's like, what?
What for?
I love curly braces and scoping. It's just what a great invention for C.
Pointer arithmetic. Explain to a newbie about pointer arithmetic.
Oh, pointer arithmetic make your head explode. And I mentioned that it was on one of my slides. I guess I didn't talk about it, but you know, everything to forth is a pointer, and it's so easy. It makes so much sense. And then you look at forth pointers, it's like, what? I have to use an ampersand here and a star there and if you get it wrong, you know, you blow up the machine.
No. That wasn't always this way. If you look at early C dialects, they had just one. There weren't any references. Either you prefixed a variable with a star, with a splat, and then it was a pointer and you were dereferencing. If you explain pointers in classic Kernighan-Ritchie C, like the stuff from the late 70s, early 80s, the stuff that came straight from the VAX, you would get pointers, wouldn't be a problem. Pointers become a problem if you overthink them and make them to references where you can have pointers under the covers, like the classic ampersand, the C++ reference, where variable is not by value, but refers to another place. Then you start confusing things. And quite frankly, Pascal, the way they did it there didn't help much. If you learn pointers on anything but forth, assembly, or C, you were setting yourself up for failure in a grandiose way. If you try to explain pointers in latest C standards by the blessed by the higher authorities of whoever cooks up C these days, you're still screwed. If you want to do pointers right, explain them like you would have done in the early 80s. Otherwise, you're doomed. You can make it understandable, but don't choose any, especially ivory tower. So, sorry, no offense. Any kind of ivory tower thinking like the C++ type with typecasts from here to the other end of the DFW Metroplex and back is not good.
So at some point,
yes,
you and I need to do a
Don,
Zoom and you teach me pointers, okay? Because I have to use C at work.
Don? somebody was saying something and I shut up.
Oh, go ahead.
Not a problem. The only thing that might become hiccupy is if your C compiler is recent and pedantic and annoying, but that can be fixed. Everything else is easy. It is not a problem.
Glad to hear it.
Okay, let me text these guys. So.
Anybody else got anything to share?
Sorry, I see most of our